This is Dr. Carroll with a video about dynamic memory allocation in C. Before we get started, let's review that in C we can have static memory allocation. For example, with int counter equals 0. Executing this statement reserves 4 bytes on the stack and initializes it to 0. For dynamic memory allocation in C, we use the library function Malloc. Malloc does two things. First, it allocates a block of memory on the heap, and second, it returns a pointer to the newly allocated memory. So where is the heap? Here's a program's memory footprint. We have headers, we have the heap. For the dynamically allocated memory, it grows down, and the stack grows up, and I'm calling that normal variables and function calls. So with that, now do you see how you can get stack overflow? To use Malloc, we need to have pound include standard lib.h. Here's its function prototype. Void pointer Malloc with parameter size underscore t size. The size underscore t parameter type is to require the size to be positive. You may be wondering why the return type is void pointer. Why not char pointer or int pointer? Remember that Malloc returns a pointer to the newly allocated memory. Pointers are just addresses, so all pointers are the same size. Also, if it returned a char pointer or an int pointer, then we'd need separate functions for each one. Furthermore, if you created your own data type, for example with a struct, how would the library function support that? So Malloc returns a void pointer, which is a generic pointer. And void pointers are generic pointers, unlike other pointers, can be assigned to other pointer types. So it's good practice to cast the pointer to the type that you need it to be. What is the lifetime of a newly allocated memory? The lifetime of the block is until the memory is freed with free. Another library function. To use free, we also need to pound include standard lib.h. Here's its function prototype, void free void pointer star. And what it does is free deallocates memory at the memory address in pointer. If pointer equals null, then it does nothing. This is a good time to bring up another important concept, memory leaks, or memory allocated that is never freed. We need to be careful of that. Let's look at an example. Let me let you pause to take it in. When you're ready, continue. Here we have just a simple example. We're including the library standard IO and standard lib for the library functions that we need, and we're going to have an array size of 10,000. Here we have the stack, the address of the stack variable, and we're just printing that out with the address of operator here, just so we can get a sense of what are the addresses for the stack, and then we'll see later what are the addresses for dynamically allocated memory. So here we declare an int pointer, and we use Malloc, and we pass it the size of int. That way the code is portable across many different systems. So it's good to use size of when using Malloc. Malloc returns a void pointer, so we need to cast it as an int pointer so that everything's happy. Once we do that, we're going to display what is the value of my int pointer, and then what is that pointing to. Now we haven't initialized it or done anything with it, so we would expect it to be random. Here we are assigning it to 42, And then we're displaying again what the value of the pointer is, which shouldn't have changed, but this should have changed. And that's for a single item if we just needed an int. But typically we're allocating things more like an array. And so here is very similar with two significant differences. One significant difference. We are now, instead of just needing one 4-byte slot or size of int, we need the array size of them. Okay, we need 10,000 of them. But notice it's also just an int pointer. Arrays are really pointers to arrays. So this is a dynamically allocated array instead of a statically allocated array. And we print out here that this is the first one on there. And just for demonstration, we could assign it a seemingly random index to a random value. Now when we allocate memory, we need to deallocate memory, and that's being illustrated here. All right, let's compile this and let's execute it. Okay, so here is the address of a stack variable. Okay, I'm on a 64-bit machine, if you couldn't tell. And then we created an int pointer, a dynamically allocated one, and notice it differs. These lower bits is where it differs from so it's just on the heap, and this is on the stack, and so they're in different places. It happens to be 0. If we ran it again, it may or may not be 0. Oh, okay, it keeps getting 0. Notice it is getting a different memory location each time. For the dynamically allocated memory, it happens to be assigning the stack. The stack variable is also differing. And then we assign 42 to this dynamically allocated variable, and it's shown here that it's being assigned. And then we're getting an array, and then just printing out the first value in the array. Some other function prototypes in standardlib.h are void pointer calloc. It takes 2 arguments, size underscore t. The name is n, and the second argument is of type size, and its element size. And so here, what calloc does is it allocates memory and initializes it to 0. So if that's important, then you can just have it do that all in one step. The other function prototype to highlight here is realloc. And what realloc does is it returns a pointer to a larger or smaller memory block of size bytes, which is specified. That's it for this video. I hope you enjoyed it.